So in this video, I'm going to run you through the 4 steps every single star in the universe go through. And I'm going to start with how stars are kind of born in something called a nebula. Now, a nebula is just a big, huge cloud of gas and dust, kind of what you see in this picture over here on the left-hand side. Now, these clouds of gas and dust are gigantic, bigger than any cloud that you've ever seen before. And they have to be really big because if you think about it, stars are coming out of these things. So, the main gases that are in these big clouds are going to be hydrogen, helium, the most abundant atoms on the periodic table, or elements, I should say, in the universe. Now, every single atom on the periodic table or element has mass. Now, since everything that has mass also has gravity, what's going to happen is that pieces of this cloud are going to begin to kind of contract in on each other where you have more hydrogen and more helium atoms. And what that's going to do is it's going to cause those hydrogen helium atoms to be squished together. They're going to bump into one another, and when they do so, they're going to be transferring their kinetic energy. And as the kinetic energy goes up, so does the temperature. And eventually we're going to go from a nebula down to this guy right here, a protostar. Now, protostars, you can kind of think of them as the teenagers of the star world. Now, protostars, as you can kind of see in this picture right here from the Hubble Space Telescope, don't look like normal stars. And they're really not stars quite yet because they are not doing the most important thing stars do, which is fusion. And they can't do fusion because they don't have enough energy. The temperature in these protostars aren't high enough to actually fuse the hydrogens together to get this star ignited. However, we do see protostars using infrared radiation. They're glowing because they're so hot. Now, eventually, the protostar will continue to collapse because the only force working on this star right here is a force of gravity, kind of pushing everything towards the center of what this star is going to be. And what's going to happen is fusion is going to begin. And once fusion begins, we get something called a main sequence star. And that main sequence star is going to take all of its hydrogen and try to turn it into helium. And now it can because the energy is so high. Temperature is very, very hot in these main sequence stars. And once fusion begins, the force of gravity that was pulling everything into each other is balanced out by the force of pressure from the fusion inside of the main sequence star. So the size of the star gets to stay the same now because the forces are balanced and we get, these spherical stars. Now, main sequence stars, well, I should say stars spend most of their time on the main sequence. It's going to take them quite a long time to take all of their hydrogen and turn it into helium. So our sun, our star, has been on the main sequence for about 5 billion years and will continue to be on the main sequence for another 5 billion years. It takes a long time to burn through all of this hydrogen. Eventually, all of the hydrogen will get used up and turn into helium, though. And at that point, we go from the main sequence to something called a red giant. Now, 2 things should kind of pop out at you. Red and giant. These things, giant, are huge. They can get up to 100 times the diameter of the star as it was when it was first a main sequence star. And the reason why it grows now is because the fusion, even though it continues, is different. Now we're taking the helium and turning it into carbon. And what that is going to do is going to kind of throw off our balance between the gravitational force and the pressure force from fusion. The inside of the star now is going to collapse down and get a little bit more dense, and the outer layers of the star are going to be able to expand. And as they expand, they cool down slightly. And remember, when we're thinking about temperature, red is not the hottest, actually kind of the coolest part. So that's why the star actually appears red, because the outermost part is cool, but the inside is actually still very, very hot because of this fusion. So that's it. Every single star goes through nebula, protostar, main sequence, red giant. Now, you can kind of see we're going to go one of 2 ways. So watch the next video and you'll figure out where we're going to go.